Hello, dear students. Since the exams for the post of the junior engineer in the state of Jammu and Kashmir are around the corner and are frequently being notified, so I'm going to start a series of videos on the solutions of the most talked about book for the exams in civil engineering, which is Gupta and Gupta. So today I'm publishing my first video as a part of the solution series to all the objective questions available in this book. So my first topic for discussion would be fluid mechanics. So the first question which is available in this book is Pascal second is the unit of. So I'm going to solve this question. So Pascal second, if we break down this unit, Pascal is Newton per meter square times 1 upon second. The first option of this question is pressure. The unit of pressure is Newton per meter square, which we very well know since pressure is force per unit area. Force is Newton and area is meter square. So Pascal second cannot be the unit of pressure. The second option, third option, which is kinematic viscosity and dynamic viscosity, look a little bit competitive. Now, we should note that there are two viscosities that we have to deal with in fluid mechanics. One is kinematic viscosity and another one is dynamic viscosity. This is kinematic viscosity and this is dynamic viscosity. Now, one of these viscosities have the unit of Pascal second. To remember this, we know that the study of motion without knowing the cause of the motion is known as kinematics, and the study of motion or the study of the cause of motion is dynamics. Kinematics, or the study of motion without the cause of motion, involves study of velocity, acceleration, etc. And the cause of motion is the force. We know that the unit of velocity is meter per second and the unit of force is Newton. So this hint will help us to differentiate between the kinematic viscosity and the dynamic viscosity. We will go and break down the units of these two viscosities, and the units of the viscosity which resemble with that of the force would be dynamic viscosity, and the units of the viscosity which resemble with the units of the velocity or acceleration would be the kinematic viscosity. Now, we have a law for viscosity, which is known as the Newton's law of viscosity, which states tau is mu times du upon dy, where tau is shear stress in a fluid layer, mu is the dynamic viscosity, or for time being, I'll just call it as a viscosity, and after I derive its units, we will name it as kinematic viscosity or a dynamic viscosity. And du by dy is the velocity gradient between the two layers in a fluid. This du by dy is also known as the rate of shear strain, which we will come to know later as we go on solving more and more questions in this book. Now, shear stress or tau is Newton per meter square. The unit of stress is same as that of the unit of pressure. So Newton per meter square, and du by dy, like I said, is a velocity gradient. So du is velocity. The unit of velocity is meter per second, and dy is the distance between two layers. So distance means meter. Now, if we put these units against this equation, we get tau equal to mu times du by dy, or Newton per meter square equals mu times meter upon second times meter. So if we rearrange this equation, we get Newton per meter square times meter times second upon meter is mu. So if we further solve this equation, we get Newton's second upon meter square is mu. So this viscosity, whose units resemble with that of force, is dynamic viscosity because it has a Newton in it. And another viscosity, which we talked about earlier, is a derivative of this viscosity. So mu is equal to, this is nu is equal to mu upon rho. Mu is dynamic viscosity, which is Newton second upon meter square, the unit which we just derived, times rho. Rho is the density, which is mass or kilogram per unit volume. Volume is meter cube. So meter square and cubic meters. If we solve or rearrange this equation, we will get nu equals Newton second meter times kilogram. Now Newton is force. Force is mass times acceleration, which is kilogram times acceleration is meter per second square times second times meter in the original equation upon kilograms. So kilogram and kilogram goes, second goes with the second, and then we have nu is equals meter square per second. If you take a look at this unit, it is purely a kinematic unit because its unit resembles with that of velocity, which is meter per second. So we are going to call this nu as kinematic viscosity. Kinematic from the unit which resembles a kinematic quantity, which is velocity v, and this viscosity we are going to call as dynamic viscosity because its unit has a dynamic quantity in it, or the quantity which we study in dynamics, which is the force or Newton. So this solves our first question. So we are going to choose option C as the answer, which is the dynamic viscosity Pascal second or Newton second per meter square. Now, taking a look at the question number 2, which states an ideal fluid is one which obeys Newton's law of viscosity. Newton's law of viscosity is, this is for question number 2, Newton's law of viscosity is tau is mu upon du upon dy. Since it's the Newton's law of viscosity, the fluid which obeys this law would be known as a Newtonian fluid. All right, and the second option is, so first option is ruled out. The one which obeys Newton's law of viscosity is a Newtonian fluid. The second option is an ideal fluid is frictionless and incompressible. So this is the real definition of an ideal fluid. An ideal fluid is one which is frictionless and incompressible. Now, the third option, which we already know is wrong, but still we are going to discuss it, is an ideal fluid is one which is very viscous. This can't be the answer for this question because an ideal fluid is frictionless. When it is frictionless, there can't be any question of viscosity. Then the last option, it's a little 50-50, 50 of the ideal fluid and 50 of a non-ideal fluid, because an ideal fluid would be frictionless and it would be incompressible. It won't have any friction in between the layers, and no matter how we are going to compress it, this fluid is not going to get compressed. So this is the definition of an ideal fluid, which we should remember for our lives, that an ideal fluid is one which is frictionless and incompressible. So the answer for this question would be B, frictionless and incompressible. That's it for the first video. See you in the next video. Thank you for watching.